Hey everybody, and thank you for joining me in this video. Hope y'all are doing well. So in this video, what we're going to be doing is we're going to be creating the first part of the update movement function. So if you remember in the last video, we went ahead and we created the update rotation, and where we set our rotation, or based on whether we're strafing or not, and also our rotation rate, whether to control our rate of rotation, whether we're in the ground or in the air, stuff like that. Pretty simple setup. But now we're going to get into the more, I wouldn't say complex, but if you've never seen my character blueprint Gasp from Scratch series, this could be a bit complex, because since I am going to be going through it a little bit fast, because I am trying to get to the animation blueprint stuff so we can get our Lyra starter animations and other stuff, because that's where the actual 60 minutes of motion matching take place. Although, like I said, and I think in a previous video, that this is truly not going to be your first 60 minutes of motion matching. It's just that the title of that blog or whatever within the Unreal dev community is just called your first 60 minutes with motion matching, if you're actually reading and following along with that instead. Of course, mine's going to be dragging out over a series of a day or so, so it's not really your 60 minutes, but with that being said, let's go ahead and get into it and go ahead and actually set up our stuff. So we're going to be in the event graph, and within the event graph, let's go ahead and create our next function, which is going to be called update movement. Because what we're going to be doing in here, and let me drag it into the movement category, is we're going to be getting our desired gait from here, as well as getting our max speed. So within other, I want to say like other YouTube tutorials or maybe projects that you've done, a lot of people, what they'll do is they'll go here into the character movement and they'll set their current speeds that they want, depending on how fast you want to go when walking or crouching, stuff like that, right? Or running. They would pretty much set it in here. However, what I like doing, and ever since I've done the Gasp from Scratch series, is I really do appreciate how the gait functionality works and how the max speed calculations are being done. I think that's very awesome, very intuitive, to where I pretty much just copy it straight up like every time, because I just can't help myself now. Either that or just start from the Gasp project as its own template, So with that being said, though, let's go ahead and get into it. So we're going to drag off of this, and we're going to create a sequence node, because we're going to want to run through a sequence of functionalities and stuff like that within our update movement. And the first one we are going to do is we're going to go through our gaits. So before doing that, what we do have to do first is we do have to set up our Gait Enumeration. So let's go ahead and go into the content drawer, and we're going to go into content, third person, blueprints, data. And in here, we're going to right click and go to blueprint. And within blueprint, we're going to select the enumeration file. And here we're going to call it eGait. So as far as a gait is concerned, so when we went over a structure file where I discussed that this is going to be like relevant data that you would place within here that you want to make changes and do other stuff, an enumeration is pretty much the same thing, albeit it's more or less like states that you'll be changing in and out, or maybe like some other stuff you plan on doing that involves switchings, stuff like that, rather than like, creating different data points like how you would with a camera. It's just like, hey, we want to switch depending on, certain things that you do. So like in this case, what we're trying to set up is we want to be able to switch, between walking, running, and sprinting. So with that being said, let's go ahead and open this up, and it's going to be very quick, very simple, very easy. We're going to add 3 enumerators that we'll be switching between. So the first one is going to be walk. The second one is going to be run. And then the last one is going to be sprint. Because if you followed along with my Gasp from Scratch series, basically we want to be able to switch between these different types within our variable that we'll be setting, to be able to, when we actually do the calculate max speeds, that we can get the appropriate speeds for each state that we get put in, whether it's walking, running, and sprinting. And also too, this helps greatly with motion matching. So, when you are doing motion matching, you want to be able to do stuff like this where we can switch between stuff, rather nicely, rather fluid, stuff like that, when it actually has to go get your animations, like your walk animations, run animations, and sprint animations. So let's go ahead and save that, and we're going to close out of it. And then in here, what we're going to do is we're going to create a variable, and we're going to call it gait, just like that. And then in here, we're going to click on the float, and we're going to look for our eGait. So when we type in eGait, we will get our enumeration gait file that we have created and set there. So now that we've done that and we compile and save, you can now see our default value, because we set walking first, that our default gait will be walk. But because we don't have any functionality set up, none of these are going to happen, but at least you could see that our values that we set up are there for us to switch between when trying to do certain things, right? So that is pretty much what it is there. So now we can go ahead and get into it. So let's go ahead and drag out a set node for this, and I'm going to move it over there and then plug that in. So again, nothing's going to happen at the moment because we're not actually like specifying anything. We haven't set anything. All we did was we created just a random variable and just assigned it values, but this doesn't actually do anything until we do the calculate max speeds. So with saying that, let's go ahead and get into the next function that we'll be creating, called the Get Desired Gait. So in your functions, go ahead and hit the plus, and we're going to do Get Desired Gait, just like that. And let's throw it into our movement. So with this, what we want to do first is we want to make it a pure, and I'm going to also, I believe with what we're about to do in here, we can call it thread safe, I believe. For the moment, I'm not going to do that, and let me just leave it pure because we do need it to be pure. So what we're going to do now is we are going to create some functionality. So now that we got our gait, let's go ahead and create a category for it. So over in your details, go ahead and create a movement category for it, and it's going to assign it there. And now what we need to do is we need to first make a variable called analog walk /run threshold. Did I spell that correctly? I think I did. Now we just need to change the type, so we're going to change it to float. And the only reason this is coming up for me is just because I have the variable outside. So, if we go ahead and, delete that, and then we can change it to a float. So when you see that kind of error pop up, that's just because you have those variables or settings or whatever within your event graphs where it has to go through and change all of those references. But if you were to just delete it, come back in here and change it, you won't get that error. So I'm going to go ahead and move that into the movement. And, or actually I believe, no, this needs to actually go into input because it deals with our input stuff. So I'm going to set that into input. And what we want to do is we want to compile and save, and we want to give this a threshold of 0.7. So the reason why I'm giving it a threshold is it's a threshold value that we're going to label basically as 70%, because there's no way to put percentages in here. The only way you can define percentages is through the use of floats, because decimals represent percentage values. There, you just have to multiply them by 100. So what we're trying to do is we're going to be calling our movement functionality in here and getting the vector length off of that, which will return either a 1 or a 0. And the reason it's going to return a 1 or a 0 is because of how their scalars are set within the movement context. So to show you what I mean by that is I'm going to open up my content browser, and I'm going to go to content, third person, input, and I'm going to go to the IMC default because I believe it's set in here. Let me go ahead and close all that, save it, and then if we go to our move, I believe it is, yeah, here. And I believe it's also in here. No, it's not. I think it's just gamepad specifically, but you can see that it has a 50, 50, and a 1 value. So within your first 60 minutes of motion matching, or these in general, you would technically set these to 1s, and then you would normalize these values, or at least within the game animation sample project, they already normalize it for you. But within the your first 60 minutes of motion matching, they change these to 1. So just like that. So these are the thresholds that we are trying to beat. That's why we set it to 70%, because you most likely have played on a game, a controller and whatnot for Xbox and PlayStations, where when you push the controller for the joystick forward ever so slightly, your character will make slight movements, and the more forward or backward, left, right you press it, the more this scalar increases until it gets to 1, because it's going in between a value of 0 to 1. So the more further up or down, left, right that you press the joystick, the closer that you get to 1. So that's what we're doing there. So let me go ahead and close that and save. So that's why we set this to 7.7, is because we're trying to represent 70% of the full 100 that we, flick our joystick, right? So what we're going to do now is we're going to do a get IA move, and we're going to get this right here, our input enhanced action values get IA move, because this is our input action that we have set up within the input action graph right here. So that's what this is doing. So what we're going to do now is we're going to get a vector length 2D length node, because what we're trying to do is within our X and Y values, or our movement, we're trying to merge the magnitude of those values into one value, so that way we either get 0 or 1, or depending on what you do. However, on a keyboard and mouse, this doesn't really matter, because you either press the button or you don't. So that's why it's like this doesn't matter, and it's more or less for the games, the controllers, that you're gonna actually want to do these things for. But for the sake of getting our proper gaits when we do certain things, we still got to set this up anyway, so it doesn't really matter. So now we're going to drag out the analog walk run threshold, and we're going to drag off and get a greater than or equal to operator, because we're trying to check that if our get movement scalar values that we had, that I showed you in the IMC default, are greater than 70%. So if we do press a button like WASD, we obviously are at a full 100% of movement. So we're always going to return true on this, in which case we're going to be doing certain things. So with that, now what we're going to do is we have to now create another variable for our movement, or I believe it's for our movement, or I think it's for our input. That's what it is. My bad. So what we're going to do now is we're going to create a new file. So if we open up our content drawer and go back to third person, blueprints, and data, within here, what we want to do is we're going to create a new enumeration. So we're going to go to blueprint enumeration, and we're going to hit E_analog movement behavior. I believe I spelled that right. I think. Sure, we'll go with it. I think, yeah, I spelled it right. So within here, now what we're going to do is we're going to create 4 enumeration values. So just go ahead and click add enumerator until you have 0, 1, 2, and 3. And then what we're going to do is we're going to call the first one fixed speed single gait. And for this one, basically what this is doing is that our character will move at a fixed speed regardless of stick deflection, is what the true description for this is. But again, a lot of this is going to be based on the fact of the joystick, but because we don't have a second movement input, we didn't go ahead and we didn't create that at all, because that wasn't going to be the point of this series. But that's what this would be doing, is we are testing for stick deflection to see if we just get a single gait, or if we do a walk run, or if we do variable speed, stuff like that. Because then our next one is going to be fixed speed, walk, run, just like that. But then, let me grab the description and move it over. That our character will move at a fixed walking speed with slight stick deflection, and a fixed running speed at full stick deflection. So meaning what's going to happen is, like, if you were to slightly press up on the joystick, that your character is just going to go at a fixed walking speed regardless. So if you had a walk speed of 300 centimeters per second and then a run speed of 500 centimeters per second, if you're below the threshold but you still have it's greater than 0, then your character is just going to walk at that fixed speed. And then when you have a greater than 70% threshold of your joystick deflection, that you just get a fixed running speed. So that's what that, of like 500. So that's what that's talking about there. Then the next one is going to be a variable speed. Yeah, I was like, I knew I misspelled that. What? Go here. Variable speed. And this is going to be a single gait. And basically what this is doing is, on full analog movement. Full analog movement control with stick, the character will remain walking or running based on a single gait input. So basically what this is doing is, like, this can have a variable speed, but you're either walking or you're running. There's no, like, no matter what your stick deflection is, you can have a variable speed, but again, you're either just walking or you're running. So it's like just kind of a regardless gait there. Because then the last one is going to be variable speed, walk, run, just like that. And then what this is going to do is, if you were to actually have the joystick deflected, but like, a little bit, but not greater than 70%, that will get different movement speeds for walking, whether you can go up to the max of 300, or you can go, anywhere between like 1 centimeter per second to 300 centimeters per second within that threshold, right? As long as you're below 70% of your joystick deflection. But then when you are above 70%, then from the 70% to the full stick deflection, you can go at different running speeds, where you can go at 301 centimeters per second all the way up to 500. So that's what that means there. So now that we got that, let's go ahead and save this. And we're going to close out and then back into here. Oops, sorry guys, it's like I gotta clear my throat real quick. So now what we're gonna do is we're gonna create a new variable called movement stick mode. And we're gonna call this one analog to get our enum. So we're gonna tie our movement stick mode to our analog movement behavior enumeration that we just created. And we're gonna move that into input, and we're gonna put it underneath the analog walk run. So now that we got that, we can go ahead and drag this out to get it. And let's go ahead and compile and save. So now you can see our different, selections there. But then we want to right click and grab a select node, because what we want to do now is, based off of our threshold, true or false, that we want to get these certain types, right? We want to get one of these types. So basically what they had was they had fixed speed walk run, and then the variable speed walk run selected for that, and then true for, or check for that. So basically what's going to end up happening is that if this is true or not, then we're going to grab the fixed speed walk run and then the variable speed walk run off of here. But then if this is false, then these will be default selected. So, however, again, with it being a keyboard and mouse movement, this is not really going to matter because we're just going to always have fixed speed and variable speed walk run. However, if you ever add the gamepad functionality, or at least like a world space, you know, for your gamepad or your joystick movement, you would then just get the like IA gamepad movement, vector link 2D, compare it to the analog walk run threshold, and then you would throw it into here, just like that. You would just do the same selection. So now with that, what we're going to do is, I believe it is a local variable that we are creating next. Yep. So off of here, we're going to right click and we're going to promote to local variable, and we're going to call it full movement input, and we're going to leave it as a Boolean. I'm going to move it up here, and we're going to connect the Get Desired Gait into it, because now what we're trying to do is set that type, whatever type that we have in here, you know, to say whether we're like true or whatever, false on whatever these selections are, to get the proper return node values that we're going to want for our gait. So what we're going to do now is we're going to get 4 branch nodes. So I'm going to hold B and click 4 times to get our branch nodes and set it up just like so. I'm going to have that up a little bit. Just like that. And now what we're going to grab is we're going to grab the wants to sprint and put it under the first branch. And then we're going to grab a wants to walk, put it under the second branch. And then we're going to grab the full movement input. I'm going to copy and paste it down here, because now what it's trying to do is we're trying to see if we want to sprint or we want to walk, and then how much of a full movement input that we have to return us certain values, right? So let's go ahead and connect these in all together. Yeah, put it that close. And then so true is going to go off the branch in front of it, just like that. And then the false is going to connect into the branch below it, because if we don't want to sprint, well, actually we do have to hook these up. I almost forgot. Because if we don't want to sprint, then we're going to check if we want to walk instead. And if we do want to walk, then we're going to do the walk. If we don't want to walk, then we're going to check to see if we want to run and whatnot there. So we're going to hook the false into here. So now we're going to add a return node, and we're going to give it an output variable. And this is what is going to be our return value. And we're going to hook it up to eGait. Just like that. So that way we can select the different values that will then determine whether we're walking, running, or sprinting. So you're going to copy this and you're going to paste it. You're going to copy this and you're going to paste it 5 times. And then let's go ahead and get it set up nicely. Just like that. So if we do want to sprint and we have a full 100% full movement input, then we want to sprint. If we do want to sprint, but we have less than a 70% threshold, then what we're going to do is we're going to want to run. So just like that. And then if we don't want to sprint and we want to walk instead, we're going to walk. But then if we don't want to walk and we have a full movement input, then we want to run. And if we don't want to walk and we don't have a full movement input, if it's less than 70%, then we're going to just walk. So just like that. Let me move that down so that way it's nice and leveled. So just like that, and now we have our desired gait set up, and that is now officially done. So I believe I could set it as a thread safe function now, I believe. No, because it's the full movement input, that's why we can't do that. Oh yeah, and the get IA move. Yeah, so anytime you have an input action in a function, you can never set that as thread safe, because that is technically like a object reference of sorts, but it's not quite an object reference. But because we're trying to get input action, we can't do that. And also too, because we're setting a local variable based off of a select node, we can't do that either. So, but we can have this as a pure function. So go ahead and close out of that, because we are officially done with that. And then we can then drag out our gaits, or we can do our get desired gait and plug it into there just like so. And I'm going to move that around just so that way I can make this bit neat. And there we go. So now we have this first part set up and ready to go. So now in the next video, what we are going to be looking at, let me pull it up for you guys, is now that we have our get desired gait, we are going to now look at the calculate max speed in the next video, where we quickly go over how to get the different speed types to then set our walk speed and our crouch speed based off of our desired gait, which you can see right here, where we check to see our gaits here. And then if we're crouching, if we want our aim, this was never in the game animation sample project. This is something that I've added personally because I want my character to have a walking speed when, you know, aiming. So that's why this is there. But like strictly speaking, these are set up within the game animation sample project. But this is what we're going to be looking over in the next video, where we're going to look over creating a float, where we're going to try to get the float value to map either a 0, 1, 2 value to the float node. And then out of that, we determine like, hey, if we're going, you know, forward, backward, left, right, that we get certain speeds to that based off of our current gait. So that's what we'll be looking at in the next video. Obviously, that was a kind of a crappy way to summarize this mess, but if you've ever seen the my character blueprint Gas from Scratch series, I do go over this in more depth, but in the next video, I will be quickly running over it. So other than that, everybody, thank you for tuning into this video. I hope it was good for you. If you did like that, you know, check out my past videos and my future videos to come, like always. But other than that, y'all have a great rest of your day and take care.